I'll briefly demonstrate how to use an interactive simulation that looks at fugacities of benzene and toluene and how they change with pressure and composition at constant temperature. We're assuming Raoult's law, which means ideal solution and ideal gas, simulations on the LearnChemE site at this location. If we look at a snapshot of the simulation, here we're looking at fugacity versus pressure. We pick the temperature. If we change the pressure, we're changing the location of this dot on the diagram. And the overall mole fraction of benzene will affect these curves. So at low pressure, we have gas, vapor, and then the fugacity is equal to the partial pressure. So as we raise the pressure, mole fraction's fixed, we're raising the partial pressure, so fugacity increases. Now, as we reach the point where we have vapor-liquid equilibrium, notice fugacity of benzene is going up and the fugacity of toluene is going down. This is because we're increasing the mole fraction of benzene in the gas phase, and we're increasing the pressure, and fugacity is that product, that partial pressure. At high enough pressures, now we have all liquid. Well, fugacity is pretty insensitive to the pressure of liquid. It changes slightly, but on this scale, it's a horizontal line. So the values displayed here for fugacity of benzene and toluene correspond to that black dot. So let's look at the interactive simulation. So here's the interactive simulation. As I change the pressure, the black dot moves and these corresponding values, fugacities, change. Now we can look at both a PXY diagram and the fugacity versus pressure diagram, give us a little better idea of the behavior. So as I change the overall mole fraction when I'm in the two-phase region, I'm not changing mole fractions in the individual phases, and so I'm not changing the fugacities. If I move the mole fraction into the liquid phase, now as I change the mole fraction, I'm changing fugacities. As I'm in the liquid phase, the fugacity is going to be the mole fraction liquid phase times the saturation pressure. Now, these simulations have some brief directions, and they have details of the calculations using Raoult's law. So if we look at changing the temperature, and we can move out of that two-phase region in the vapor phase, but notice if you gas these two components, it's not changing. That black dot indicating fugacity is not moved because changing the pressure changes fugacities, but changing the temperature is not changing fugacities.